position, velocity, and acceleration of some object. If s at t is a function that represents the object's position, then v at t, which is the derivative of s at t, would represent the instantaneous velocity of that object. And if you took the second derivative, then that would represent the acceleration of the object. Typically, we measure s at t, the position, in meters. That means that if t is in time, then the velocity will be measured in meters per second, and a at t will be measured in meters per second squared. A couple things to note about these kinds of problems. One, direction is important. It has some significance. So if your position is positive, that means that you are right of the origin. You're on the right side of it. If your position is negative, that means that you are in the left side of the object. If your position is 0, then that means that you're at the origin. Some other things in problems, if it says initial position or initial velocity or initial acceleration, that means when time is equal to 0. That's what you'd be subbing in. If it says stopped or changes directions, which is a key one, or the object is at rest, that means that the velocity is 0 because it's not moving. Average velocity, of course, is like your average rate of change. This would be the average rate of change of your position function. So that would be s at t2 minus s at t1 over t2 minus t1. And if I ask you the average acceleration, that's not the derivative of the velocity function because it's an average rate of change, meaning between 2 points in time. So when the average acceleration would be counted by taking v at t2 minus v at t1 over t2 minus t1. Okay? So let's do an example. Let s at t represent 4t, or let s at t equal 4t cubed minus 9t squared minus 30t plus 8. It says that represents the position in meters and t is the time in second. Find the position when the particle changes direction. So what does it want us to find? It wants us to find the position. Because it wants us to find the position, we want to find s at t. But we don't know what time does it want that position at. So we have to go find time first. What does it tell us? At what time does it want that to occur? It says when the particle changes direction. So when a particle changes direction, it's going one way, but then it starts to go a different way. At that instant that it changes direction, for a brief moment, the velocity is 0. So we want to find the time at which the velocity is 0, and then sub that into the position function because now we'll know the time that it wants. So we know that v equals 0. So let's find what v is. V at t would be the derivative of s at t. It's simple power rule here, so we get 12t squared minus 18t minus 30. And because v at t, the velocity is going to be 0, we'll set that equal to 0 and solve. We can start to set it equal to 0 by by factoring. So we can factor out at 6. So we get 2t minus 3t minus 5. So now we have to find two numbers that multiply to negative 10 and add to negative 3. Once you factor that, you'll end up getting 6, 2t minus 5, and t plus 1. So that's just factoring a hard trinomial. Now we can solve for the times. We get t is equal to 5 over 2, or 2.5 seconds for this one. And then for this one, we get t is equal to negative 1. Now, time can't be negative in these situations, not usually anyway. So the time of negative 1 will not count. We only care about the position at 2.5 seconds. That's the only time that we care about where it changes direction. So now we can go and find s at 2.5, which means that we go and we sub it into the s at t function. So that's going to be 4 times 2.5 cubed minus 9 times 2.5 squared minus 30 times 2.5 and then plus 8. So when you type that all into your calculator, the number that you're going to get is negative 60.75. And of course, that's position, so it's measured in meters. So In order to find the position where it changed directions, we needed to know first the time where it changes direction. We found that by setting the velocity equal to 0 and solving for t, and then plugging that back into s.